In section 3, we're going to work with a different type of sequence. Now we're going to be working with geometric sequences. And if you remember from my introduction to this chapter, geometric sequences are based on exponential functions. Okay, so they're exponential growth or exponential decay. And we still are going to follow the same rules about finite or infinite series when we look at them. So a geometric sequence is a sequence that follows a geometric pattern instead of an arithmetic pattern. You'll have a common ratio. Remember, when we found a common difference, difference is found by subtracting. So we would subtract the term before from any term. So I take term 2 and subtract term 1. Take term 3 and subtract the term before it, which would be term 2, and I find a common difference. In this case, we would take, and since we're talking about ratio, we would be dividing. So a sub 2 divided by a sub 1, a sub 3 divided by a sub 2. So you find the common ratio by taking a term and dividing it, that's because it says ratio, by the term before it. Okay, and then a geometric series is, again, adding a range of terms from a geometric sequence. So very similar to what we learned about arithmetic sequences. Type of problem we might have for a sequence, a geometric sequence, would be something like this, where we know that we have box office revenue that starts at a certain value, and for a range of time it increases by a certain amount per year. So this is a geometric type of function. And when we go through by the end of the lecture, then I'll show you how to go ahead and do an authentic problem like this. But in the meantime, let's make sure we can do the basic skills. So first thing I would need to do is I would need to find the common ratio and determine whether or not I have a geometric sequence or not. So 4 divided by 1 would be 4. 8 divided by 4 is 2. 16 divided by 8 is 2. So this is neither, right? This does not fit the arithmetic or the geometric, right? 4 minus 1 is 3, 8 minus 4 is 4. I don't have a common difference, and I don't have a common ratio. Okay, so let's try this. 2/3 times 3 over 1, that's dividing by that, equals 2. I'd have 4/3 times 3 over 2. 4 divided by 2 is 2. Right, so, and I'd have 8/3 times 3/4. 8 divided by 4 is 2. So in this case, it's geometric. I found a common ratio by dividing. And in this case, my common ratio is 2. Okay, if I have 1 divided by 1/2, that's 2. If I have 3/2 divided by 1 is equal to 3/2. So that's not geometric, but 1 minus 1/2 is 1/2. 3/2 minus 1 is 1/2. 2 minus 3/2 is 1/2. This is arithmetic. So first I tested for geometric, then I tested for arithmetic. My common difference is equal to 1/2. Okay, so we could find geometric, we could find arithmetic, we could find neither. Remember, I find a common difference by subtracting. I find a common ratio by dividing. So go ahead and practice that. Do problems 4 and 5, and then come back to our lecture. Now, if I want to write the rule for a geometric sequence, I can use this formula. A term is equal to the first term in the sequence times the common ratio to the n minus 1 power. So I would need to find the common ratio and the first term. So here they've given me a sequence. I know that negative 4 divided by 1 is negative 4. 16 divided by negative 4 is negative 4. Negative 64 divided by 16 is negative 4, so my common ratio is equal to negative 4. My first term, a sub 1, is equal to 1, and I can plug those in here. A sub n will be equal to 1 times my common ratio, negative 4, to the n minus 1 power. That's the rule. Now remember, I will never be able to multiply a sub 1 times my common ratio because I have a variable in my exponent. I would have to do exponent before I can multiply. Order of operations tells me so. Okay, if we look at another example of this, 18 divided by 6 is 3, 54 divided by 18 is 3, my common ratio is 3, and my first term is 6. So a sub n, any term, will be equal to 6 times 3 to the n minus 1 power. Okay, again, if I wanted to check to make sure I had it correct, I would take the numbers 1, 2, and 3, 1, 2, 3, and 4, plug them in for n and simplify, and I should get these outputs. Right? So if I take 6 times 3 to the 1 minus 1 power, 1 minus 1 is 0, 3 to the 0 power is 1, times 6 is 6. It works. Okay? So you can always check your work if you want to, if you're not sure if you've written the rule correctly. Okay, in this case, I'm not going to take the time to do that, but it is very simple to do. Okay, now, as before, we learned this in arithmetic sequences. Giving me the sequence is one way to do it. When they give me the sequence, I find the common ratio, I find the first term, and then I go ahead and I write the rule. So remember, I still want to find the common ratio. Here's my common ratio. And then they didn't give me the first term, they gave me a different term. So I know that 15 is a sub n, and n is 2. So I don't know the first term, but I'm going to find it. I know that my common ratio is 1/2, and in this case, when n was 2, a sub n was 15. That's what I found out. So a sub 2 is 15. The 2 goes here, right? This becomes 15 is equal to a sub 1 times 1/2 to the 2 minus 1 power, 1/2. If I multiply both sides of my equation by 2, that gets rid of the 1/2. So I find that a sub 1 is 30. Now I go ahead and go back to my rule. A sub n is equal to a sub 1, which is 30, times 1/2, the common ratio, to the n minus 1 power. And that's my rule. Okay, I'll do that one more time. My common ratio is 2. I know that a sub 2 will be equal to a sub 1 times my common ratio to the 2 minus 1 power. Okay, 2 minus 1 is 1, so this becomes 6 is equal to a sub 1 times 2. If I divide both sides by 2, 3 is equal to a sub 1, and now I write my rule. A sub n is equal to a sub 1, which is 3, times my common ratio, which is 2, to the n minus 1 power. So that's another way that I might write the rule. Okay, and as we did before, we can also do this by creating a system. When they've given me 2 of these, I can write the equation out twice, and now I'll have to find both a sub 1 and the common ratio. But look at this, they gave me a sub 1. That's nice. So I could go ahead and find the common ratio potentially here as well, because I know what a sub 1 is. So keep an eye out for that. I could write a system, but it may not be necessary. So I know that 12 was equal to a sub 1, which is 3, times my common ratio, which I don't know, to the 3 minus 1 power. So I know that 12 would be equal to 3 times the common ratio squared. If I divide both sides by 3, 4 would be equal to my common ratio squared, and then I would want to go ahead and take the square root of either side. R would be equal to 2. Now you might ask, why isn't it plus or minus 2? Well, it could be plus or minus 2, but you'll find that if I plug negative 2 into one of these scenarios, I'm not going to get the same terms. Okay, so let's go ahead and write our rule. We know that a sub n is equal to my first term, 3, times 2 to the n minus 1 power. Okay, in this case, they also gave me a sub 1, so I really don't have to write a system, but I'm going to do that anyway, because if they gave me a sub 2 or a sub 3 instead of a sub 1, then I would have to do that. So I know that 1 would be equal to a sub 1 times r to the 1 minus 1 power. And I know that 625 is equal to a sub 1 times the common ratio to the 5 minus 1 power. Now, what's interesting about this, though, is when I simplify this, I'm still just going to find out that a sub 1 is equal to 1, because r to the 1 minus 1 power is r to the 0 power, which is 1, and I get a sub 1 is equal to 1. Okay, when I go ahead and plug the 1 in here, 1 times r to the 4th power, I know that r will be equal to the 4th root of 625. Right? What is the 4th root of 625? Well, let's go ahead and I'm going to plug it into my calculator. So I take 625 and I'm going to take it to a power. I'm going to take it to the 1/4 power because that's the 4th root, and it's equal to 5. So now that I know that r is equal to 5, I can write the rule. A sub n is equal to 1 times 5 to the n minus 1 power. Okay, and that's, so you might write out a system like this, but when they're supplying you, remember what you're always looking for is you're always looking for a sub 1 and the common ratio. Those are the two things that you need. Okay, if they gave you one of them in the supplied information, great, it just cuts down the amount of work. Okay, so practice that. Go ahead and do these problems. They're all about how to write the rules, 19, 21, 31, 32, 41, and 42. A couple of examples of each different method, and then we'll talk about series. So I have a rule for finding the sum of a finite series. This is the rule. And what I need to write the finite series is similar, right? I need to know a sub 1, I need to know how many terms, and I need to know the common ratio. Okay? So these are the parts that I'm going to need to find. Now, what's nice is that if I'm in the standard form for the rule, right, I know that a sub 1 is equal to 6, and I know that my common ratio is equal to 4 because this is the first term, and this is the common ratio. Okay? So when I plug those guys into here, I want to find the sum of 8 terms. So the sum of 8 terms will be equal to the first term, 6, 1 minus 4 to the 8th power over 1 minus 4. Okay, so that will be equal to 6 times, this will be negative 3, and 1 minus 4 to the 8th power. Well, let's find out what 4 to the 8th power is. So 4 to the 8th power is 65,536. So this will be negative 65,535 because it was 1 minus that. Let's go back to my calculator and I can divide that number by 3. And then I'm going to multiply it by 6. So I get 131,072. So 131,72. 072. So the sum of the first 8 terms is equal to 131,072. Right, now this one's a little trickier. First off, they're asking from the 0 term to the 7th term. And they're also, this is not in the correct form because you see it's not I minus 1. Okay, so the first thing I need to do is I need to figure out what is the first term. So if I plug 1 in for I, 12 times negative 1/2 to the first power, this becomes negative 6, right? So I'm finding a sub 1. 12 times negative 1/2 is negative 6. Now if I want to write the rule is negative 6 times negative 1/2 to the n minus 1 power. Okay? So the first, right, this was 12 is a sub 0. So I'm going to write that down. Right? When I plug 0 in here, 0 minus 1 is negative 1. Negative 1/2 to the negative 1 power is negative 2. Negative 2 times negative 6 is 12. So a sub 0 is actually 12. I'm going to need that later. right? But now I'm going to take my first term. So the sum, I'm going to find from 1 to 7. So the sum of 7 terms is going to be equal to a sub 1, which is negative 6, times 1 minus my common ratio, which is negative 1/2, to the 7th power, all over 1 minus negative 1/2. Okay, so some tricky stuff here. So it's going to be negative 6. I know what the denominator is going to be. 1 minus negative 1/2, that's 1 plus 1/2. That's going to be 3/2. Okay, so that's helpful. And then in my numerator, I need to take negative 1/2 to the 7th power. Okay, so I know it's going to be, right, if I take a negative number to an odd power, I know it's going to be negative. So what I can do now is I can take 0.5 and take it to the 7th power. It's a very small fraction. What I could do instead, because I think I'd rather have fractions, I'm just going to figure out the denominator. 2 to the 7th power is 128. So I have 1 minus negative 1 over 128. Ugh, complicated, right? But that becomes minus a minus, that becomes, I'm going to have negative 6 times, I'm going to take the numerator, right? This is going to be 129 over 128. Yuck. And I'm dividing by this, so I'm going to invert and multiply. And this is what I'll get. So I'm going to take, right, 3 is going to go into negative 6 and leave negative 2. The negative 2 will go into 128 and make it 64. We still have the negative, though. 2 goes into 64 and make it 32. So this simplifies to be negative 129 30-seconds. You might end up doing this and coming out with some sort of a wacky decimal. I preferred to work with it in fraction. Okay, it doesn't make any difference how you do it. I could have converted to decimal along the line, but I think it's much better for you to work in fractions because you stay focused more on what's happening with factors and other things. So go ahead and practice finding the sum of the series. Remember to keep an eye out for items that aren't in the same term. Oh, and I made a mistake. Remember, I forgot this. This was 7 terms. I need the 8th term. This is going to have to be plus 12. So I'm going to need common denominators. So let's go back to my calculator. 12 times 32 is 384, and then I'm going to have to subtract 129, 255. So this becomes 255 30-seconds. So what I did there really quick in the calculator is I created common denominators, and I had negative 129 plus the 300 and some odd that I got when I created the common denominator. So this actually is the answer. So remember, I had to add in the 0 term after I found the sum of the first 7 terms. Okay, so be very careful in reading sigma notation. Make sure your rule is actually in the correct form. If it's not, you have to put it in the correct form, which is what I did right here. Okay, that's how you do it. Get a little practice, do 51 and 52, and then we'll finish out the lecture. So here, when we take a look at this particular problem, it says that it increases by 5.9%. So that's 0.059. And remember, that's going to be added to 1. Okay, so if I wanted to write this as an exponential function, I know that my amount would be 5.02 times 1 plus 0.59 to the t power, if it's per year. So this is kind of what it would look like, right? And in this particular case, if I want to go ahead and write this out, I know that this is my first term, and I know that this is my common ratio. So I know that a sub n will be equal to the first term, right? So we're making this year 1, right? 5.02. That's important to think about because in this scenario, which is the exponential function you worked with before last semester, in this scenario, 5.02 is actually the value for year 0, right? Here we're calling it year 1, right? N equals 1 represents 1990. We don't start from 0 here. My common ratio is 1.059 to the n minus 1 power. Okay, so that's the rule, right? So remember the things I'm looking for a sub 1, and I'm looking for how to find the common ratio. So this is the common ratio, and that's a sub 1. Okay, now they want to know what the box office revenue was for the entire period. So that means I need to add it up, right? So I'm going to write this now in summation notation so that you can think about it. I'm going to start with n is equal to 1, and we're going to go to 2003, so that's 13 years. And my rule is 5.02 times 1.059 to the n minus 1 power, 9. And I want to find the sum of 13 terms. It's going to be equal to my first term, 5.02, times 1 minus my common ratio, 1.059, to the 13th power, all over 1 minus 1.059. Okay, so if I want to go ahead and simplify this, this will be 5.02. I'm going to do a little bit of the work, right? 1 minus 1.059, that's negative 0.059. Right, now I'm going to go back to my calculator. Now I know that this is going to be a positive number. I'm going to subtract it from 1, so it'll be a negative number. I'll divide by a negative number. I know my result's going to be positive, so I can kind of forget about that. And let's go to the calculator, and I'm going to take 1.059, and I'm going to take it to the 13th power, and that's what it equals. And then I'm going to subtract 1, and then I'm going to divide it by 0.059. Okay, now this is what I would end up in the parentheses here. Now I need to multiply it by 5.02, and so what I get is 94.18. 94.18, how many dollars? Billion dollars. Okay, so that's working through and using it in a real life sort of example. And that's the end of 7.3.